Hello everyone, welcome to my channel, and today I want to show you a quantum physics experiment. Now today we're gonna study a quantum tunneling. So here we got a generator, as you can see, generator which has a wavelength of 2.8 centimeters, as you can see. Now and it's off now, but it will be set on continuous wave. Now there's a modulation as well, but we don't bother about that. And here we have a detector, which is very important. Now you can see it's off at the moment. So yeah, actually no, it's on, but it's reading 0 because no signal. Now I'm gonna go ahead and turn the transmitter on, and we will see what happens. So here I turn the transmitter on, the power light is on, and here we can see we get a 100% signal coming through. Now, if you know a little bit about physics, you know that the quantum tunneling is possible. So in quantum, see, it's reading 100. With 10, it's the scale of 10, but it's about 100% signal. So it's reading, yep. So it's reading 100% signal. Now, what happens if in quantum, in a classical physics, if there was some kind of a signal coming through here, and if we put a barrier on it, what would happen normally in classical physics? We have for example, had a ball coming through, it bounces, it hits the barrier, bounces off. In quantum physics, a little bit different. There's a chance for the signal, or for the wave, or for the particle, photon, to actually travel through the barrier, and that's what this experiment is all about. Now, if I put this aluminium sheet, and you can see that the signal reading 0. So the scale, you can see that it's set to 0. It's reading 0 now. Now, if we now you can see it's reading 0. But in quantum physics, saying that there's a small chance for for some particles to go through the sheet metal plate, or a potential barrier. So we're gonna scan the gain now and see if we're getting any small portion of signal. Let's increase the gain. Oh, we're getting something. It's not reading 0 completely. Now let's increase it higher. Alright, so we're getting a small, you can see it varies. Now, like, look, I'll show you a proof. So if I turn it off, if I turn the transmitter off, you will see the signal is, maybe there's some, it's reading a little bit, but that's just because of calibration. But yeah, so you see there's no signal, pretty much it's 0. Now, if I turn it on, and continuous wave, you can see that it's reading some small percentage of the wave is coming through. So in quantum physics, this is actually proves that the wave that travels from the particle, or the wave that travels, most of the signal here actually hits this side of the plate and gets reflected back. But however, because of the quantum physics, because we're dealing with the waves here, there's some portion of signals going through. Now, how is it possible? And the funny thing is, the best thing is that this metal plate is so thin that particles cannot exist inside it at all. The particles come through. It has a wavelength of 2.8 centimeters. So 2.8 centimeters is about this much, and this wave actually cannot exist inside the barrier. So what happens with a photon, it coming in, instead of hitting this some percentage, instead of hitting it and it gets reflecting, it jumps on the other side and continues on. This what it shows. This proof shows here why the quantum tunneling is actually a real thing. So here we're getting a signal that coming through this steel plate, and there's a small percentage you can see because I increased the gain to three times. So yeah, and so we actually getting it. This is shows that proof of quantum tunneling is possible. Now this is really great. I love this experiment because it's it explains pretty much what quantum physics is all about. So yeah, this is what I wanted to show you guys. This is what shows that this is the proof that we're having here. So it's not just some waves going around. We can probably put this because the wave, actually funny thing is the wave here has a weaker signal, so it's better to have it closer. Like we close here, so you can see that some signal it varies, but still there's a small percentage coming through. Yeah, there's definitely like some sort of a amount coming through, but yeah. So the most of the wave, maybe 99% of it hits the. I didn't calculate this because I don't have the measurements, but 99% hits this barrier, gets reflected, and a small percentage, or maybe 1%, maybe less, actually tunneling through. Now, this is incredible. This is just incredible. So this shows that the quantum physics is correct, and quantum tunneling is a proof. Now, yeah. So I'd just like to leave it at that, and I hope you like this experiment. You can see that yeah, that the signal is getting because the barrier is closer, is blocking more wave, but nevertheless there's some signal coming through, and it's not noise, because if I turn it off, you can see it goes to almost zero or some sort of a small percentage. Now there's a signal, so this is a proof. Okay, so thank you very much. I hope you liked this video, and yeah, I hope I can make more videos like this. It all depends on my circumstances, but yeah, life is, yeah, full of opportunities. Anyway, thanks for watching, and yeah, see you later. See you next time. Bye.